The proposition that our universe is a high-fidelity computational construct has moved beyond abstract thought experiments and into the territory of mathematical probability. But exploring this possibility creates a lethal paradox. If our current scientific understanding is correct, finding empirical proof that we live inside a computer might be the very trigger that forces our creators to pull the plug. This shift toward a probabilistic model began in 2003, when Oxford philosopher Nick Bostrom formalized the simulation trilemma. The argument assumes substrate independence, the idea that conscious experience can supervene on any physical system, whether it's biological neurons or silicon microprocessors, provided it implements the right computational structures. This chart tracks the volume of conscious minds over time. If even a small fraction of civilizations reach a post-human stage and choose to run historical simulations, the number of digital minds will eventually outnumber biological ones by billions to one. Under the bland indifference principle, if you cannot distinguish your experiences from those of a simulated entity, you are statistically likely to be one of the trillions of minds living in the code rather than the handful in base reality. If the math suggests we are simulated, the next step is to search the physical universe for the hardware running our reality. But that search immediately hits an insurmountable wall in the laws of physics. To render a universe this vast, a simulator would need a computer of unimaginable scale. But physics dictates that even the most advanced hardware has a maximum limit. Information is physical. Every bit of data processed or erased requires finite energy and mass, meaning the code governing our universe is bound by the same laws of thermodynamics we observe. This schematic shows Landauer's principle and the Bekenstein mound. Erasing data dissipates heat, and excessive data density causes gravitational collapse. Simulating quantum Earth requires a globular cluster's energy. This Jupiter-sized computer would ignite from computational heat before collapsing into a black hole. These calculations prove that a high-fidelity one-to-one simulation of our reality is strictly prohibited by the energy available in the visible universe. Because a perfect render is physically impossible, our universe must use a form of lazy rendering, an optimized, compressed environment that only creates high-resolution detail when an observer is watching. Physicist Melvin Vobson believes we can see the signatures of this compression through a new framework, the second law of infodynamics. This theory posits that information is a fundamental state of matter with its own physical mass. It suggests that the universe naturally minimizes its information entropy over time to stay computationally efficient. We see this efficiency in biological systems. Genetic mutations in viruses appear to evolve in ways that decrease information entropy, acting like a natural data compression algorithm to save processing power. This optimization likely involves fully homomorphic encryption, a method from computer science allowing a system to process data without ever knowing what that data actually is. In this model, the parent civilization runs the simulation using scrambled encrypted data. The creators can compute our reality, but they cannot directly observe our internal experiences or thoughts without the specific decryption key. If our universe is an encrypted, compressed black box, then any attempt to hack the source code or detect a glitch isn't just a scientific experiment, it's a threat to the integrity of the system. Philosopher Preston Green calls this termination risk. It is the idea that our existence depends on staying useful and cost-effective to the post-human civilizations running the program. Simulators are likely bound by strict scientific budgets. Under the matrix funding inequality, they will only fund narrow experiments with specific goals. They have no reason to sustain an infinite, open-ended world that consumes excessive power. If humanity begins building its own planetary-scale simulations, we would place an enormous, unplanned computational load on the parent servers, potentially forcing an emergency shutdown. Worse, if we conduct tests that explicitly prove the simulation exists, we contaminate the experiment.
If the purpose was to observe natural development, our discovery makes the data useless. At that point, the most logical move for the simulators is to reclaim their resources by instantly terminating our universe. This modern fear mirrors the ancient belief of Gnosticism that the material world is a flawed prison built by a lesser programmer known as the demiurge. It resonates with Plato's allegory of the cave, which suggested that what we perceive as reality is actually just a shadow cast on a wall by a higher truth we cannot see. But while the ancients thought waking up to the illusion was a form of salvation, modern physics suggests it would be the end of the program. Investigating the fundamental code of the universe is a catastrophic risk we may not be able to survive. We should perhaps leave the mystery buried, because the moment we turn around to see the simulation, the architects may decide it's time to turn us off forever.